This is the video presentation for SaSiMa, a sampling sites manager for optimal sampling. With our sensors, we're able to observe and document the broad biodiversity among us. The monitoring of biodiversity is increasing demand. Nowadays, with the rise of technologies such as sensors and image capturing devices, are supporting the monitoring of biodiversity that is usually based only on human recognition or detection. However, we need to consider that there is also hidden biodiversity, and most of it actually lies under your feet. Biodiversity in soil. Biodiversity in soil is just as important as above ground, and a way to achieve this is by sampling and sequencing the DNA in the environment, identifying to which organism it belongs to. The sequencing technique applied on soil has the advantage to observe communities for samples. Many people are applying this sampling technique, and while this is generating a lot of sequencing data, the data is annotated and scattered among different files, such as spreadsheets. The data stored in this way lacks structure, and direct associations to location of sampling sites and to assigned taxonomy names is not directly accessible. This lack of organization and integration of the data prevents to provide the sequence diversity and species richness over different scales of spatial regions and taxonomic levels. For this reason, we came up with the idea of illustrating a single-page web application to support the user's need to observe informative data. The web application provides direct access to the data resource annotations, permits to visualize the important associations linked to the researchers that have collected the samples, direct access to the processed sequencing data from the sample sources, and display the location information of where samples have been collected. The application aims to help to planify or re-evaluate the sampling strategies and to keep track of the metadata and results. And most important, it should get fun to play and interact with the heat map. Okay, I will now show you a quick demo video of our application itself. Okay, in the web interface, there are multiple tabs that you can see on the top left side. There are samples. Here you can see the collection of samples, sampling events. Here you see the collection of events and sampling sites. We work the most part on sampling sites, especially on the specific sampling sites. You can go to the sampling site if you click on it. Here you can see different data or data representations. On the left you see a heat map. This is the collection of samplings. On the right you see where the sampling event took place. When you hover over a subplot or a single cell, in this case, you see which ID it has and what the value it was. -1 stands for there's no value for this cell, so it's also gray, and that's part of the heat map scale. On the bottom of the screen, you see all the samples that are taken. You can also see occurrences and samples again. Okay, when you click on a single cell, it will highlight the data below and also on the heat map itself. There's also a button switch. When you click on it, it will show the similarity. This will show the similarity between cells itself. So when you click on a cell, it will show the similarity against all the cells. Okay, this is it. The heat map strategy has great potential to extend the accessibility of the data obtained from other resources. For example, it would be useful to include publicly open data to extend communities between sampling sites from different studies which share the same characteristics, such as spatial region tenures. Another extension is the visualization of the biodiversity dynamics across multiple sampling events by using temporal charts and to include sample features, such as bioclimate factors that can be used for community comparisons. At last, the data were collected and integrated in the heat map can be used to determine species area ratio. This is our presentation. Thank you.